Now look at present value. The present value, well, obviously that is the value of a sum of money as it is today. But also it is the sum of money that we need to invest today to arrive at a known sum in the future. So for example, you know that in order to pay for a car or some fees or an installment, you have a known future value, 5 lakh, at a known point of time in the future. How much do you need to invest today to arrive at that known future value? That is the present value. Present value is a very critical concept. It's used, as I've mentioned before, widely. So if you look at today's value, right, as I've already mentioned earlier, at some point of time t in the future, as money earns value, it turns into the future value, a process called compounding. Now when we know the future value, in order to arrive at the present value, that is today's value, by the same time period t, the process is called discounting, because we strip the future value of its earnings, or we discount it to arrive at the present value. Now we know the formula for future value, which is PV, present value, into 1 plus R raised to t. Similarly, future value, you just divide it by that factor, 1 plus R raised to t. The same rules, that is R and t must be in the same units, that rule holds. Let's look at an example to illustrate this. Yeah? So I'm using an example which is there in the courseware. So a pension fund manager must pay out funds of INR 1 crore 6 years from now. There you go, we have the future value and we have the time period. Assuming an annual interest rate of 7% must be earned on any investment made today, how much must he invest today to realize that INR 1 crore in 6 years? So we know the future value. We are being asked what is the present value of that INR 1 crore. So let's use this little table. We have 1 crore, which is 100 lakhs. What is R? It is 7.5%. I'm just formatting the cell. Then what is T? 6. So therefore, what's the present value? It is the future value divided by 1 plus R, right? Which we will now raise to the time period T. And tell me, do you think it will be less or more than the future value? Remember, we're discounting it, so it will be less. And there you go. 6 years later, 64.79 lakh turns into a crore, assuming that it is earning 7.5% per annum. Okay, so this is the present value, this is the future value. We arrive at a crore from 64.79 lakhs by compounding. We arrive at the reverse by discounting. Let's look at another example. So a builder has 2 sets of apartments, Ganga and Jamuna. Both are identical in every respect, they're just beside each other. Ganga is complete, but the work on Jamuna has just started flowing. So for an apartment in Ganga, you have to pay 55.5 lakh for immediate purchase. For Jamuna, it's an installment payment schedule, and this is the payment schedule. That today you pay 7.5 lakh, 6 months later 15, 6 months after that 17.5, and then in the 18th month 20 lakh. Which one is cheaper? Well, if I look at the two numbers, it seems apparent. But this leads us to a very important concept. When you are looking at money at different points of time, you cannot compare them. you can only compare cash flows which are at the same point of time. Typically, we compare cash flows, we compare the cash flows as of their value today. That is, we compare the present value of two cash flows. Now for Ganga, I already have the present value, right? 55.5 lakh. But for Jamuna, I do not have the present value. I have the value split into different points of time in the future. Therefore, this apparent summation 60 is not the same as summing all these as of today, right? In other words, if I were to make a lump sum payment for Jamuna today, like I'm doing for Ganga, what would that lump sum payment be? In order to find that out, we need to present value all of these future cash flows, right? So let's do that. Can you tell me what would be the present value of 7.5 lakh? It's 7.5 because this is getting paid right now. It's already present valued. Now, if I look at 15 lakh, very clearly I need to present value it by 6 months, right? So my T is in units of 6 months. Therefore, let me take an R of 6 months too. But hey, where is the R? What is the R we need to take, or what is the discounting rate? Now, that is an important question when it comes to present valuing. We take an R which is relevant to the situation. What does that mean? Now, in this particular case, let us say that instead of investing in Jamuna, your money is sitting in a fixed deposit which is giving you 10% per annum. So, therefore, let us use that as our discount rate, 10% per annum, and find out what the present value is. So this 10% per annum, we have to take a 6 monthly rate, or 5% for every 6 months. So I'm going to present value my 15 lakh divided by 1 plus 0.05, right? That's 5% raised to 6, no, raised to 1, because it is 1 6 monthly period. And we get the present value of 15 lakh. Similarly, I'm just going to drag this and replace the 1 by 2, because we have 2 6 monthly periods and 3 6 monthly periods, and then sum it all up, and that will give you the lump sum equivalent of a Jamuna repayment. And there you go. This is the present value, and let me just reduce the decimal places. So it's 54.94 lakhs. So actually with Jamuna, you are paying less than for Ganga, and you have the advantage of paying in installments. So this is equivalent to, or can be compared to this. So this is a lump sum present value payment for Jamuna. The same thing can be expressed as installments over a period of 18 months. So this is the same as paying out 54.94 lakh today, right? So we've learned two important lessons. One is that present value is the value which is invested today. To arrive at a known cash flow in the future, we need to calculate it by dividing it by 1 plus r raised to t. And second, and that will lead us to our next concept, which is NPV, that money at different points of time has different values. If you want to compare a sum of money 1 year from now and a sum of money 6 months from now. You can't do that unless you bring both of them to the present. That is, unless you discount both of them. So when you have cash flows at different points of time and you're comparing them, you need to bring all the cash flows to the present, a process which is called discounting, and you need to use an appropriate rate which is called the discount rate. And the next concept we will talk about therefore is a concept called net present value or NPV.